So if you wondered where those derivative rules for the inverse trigonometric functions came from, I'll show you how to find the derivative of the inverse sine function. You can, if you get excited and you want to see the other ones, you can check them out in your book or other online sources. So we're going to use implicit differentiation to find this derivative. If y is the inverse sine of x, I can take the sine of both sides. Since sine and inverse sine undo each other, I'll get the sine of y on the left equals the sine of the inverse sine of x. Sine of inverse sine of x is just x. So here's my new equation. Sine of y equals x. Now I can take the derivative of both sides with respect to x. That's going to be the derivative of sine of y with respect to x is cosine of y times dy dx. And the derivative of x is 1. Divide both sides by cosine y to get dy dx by itself. And I get dy dx equals 1 over cosine y, which is fine. We've seen derivative formulas that have both x and y's in them, but not the kinds of derivative formulas that we publish in a textbook. So could we use what we know now to write 1 over cosine y as a function of just the variable x? So watch a little trigonometry magic that we can perform here. Hope you remember the Pythagorean theorem and how it applies in trigonometry. The sine squared of y plus cosine squared of y has to equal 1. Sine squared of anything plus cosine squared of anything has to add up to equal 1. So I'm going to try to get cosine y by itself. So I have cosine squared of y. I'm going to take the square root of both sides. When I take the square root of both sides, the square root symbol means to just take the positive square root. So I'm going to have to put the plus or minus sign here in front. But now I have to think about what I know about inverse sine of x. Inverse sine of x is only defined for the domain negative pi over 2 to positive pi over 2. So, since we know that y has to be between negative pi over 2 and pi over 2, if I take the cosine of values between negative pi over 2 and pi over 2, the answers are always positive. So I know that the cosine of y has to be positive. It means I don't have to leave the plus or minus sign there. I can just choose the positive branch. So here, I'm over here on the side, I'm doing a little trigonometry magic to try to find another way to write cosine of y. And I was able to. I've rewritten cosine of y as the square root of 1 minus sine squared of y. Still, I have a y, but watch what happens. Remember that sine of y equaled x. So every place I see sine of y, I can replace it with x. So 1 over cosine y, I can replace 1 over square root of 1 minus sine squared y. And now every time I see sine of y, I'll replace it with x. This is how I get the derivative formula for inverse sine of x. 1 over the square root of 1 minus x squared. I do not need you to know this for the test. I do not need you to know this for my test. This is just to help you understand where we got these formulas from if you want to see their derivation.